In this problem, I'm supposed to optimize something concerning a box that's being manufactured. It says that I have a rectangular box with a square base. It's supposed to have a particular volume, 768 cubic inches. The material used for the top and bottom of the box costs $3 per square inch, while the material used for the sides of the box costs $2 per square inch. So the sides are less expensive than the top and bottom. Find the dimensions of the box that minimize the cost of the materials. So I'm going to have to minimize the cost. That's the quantity I'm trying to minimize. I'm going to have to come up with an expression for the cost of the materials. I'm going to have a way of representing that symbolically. So I'm going to set up some variables by drawing a picture of this box. So I've got this rectangular box. It's supposed to have a square base. So that means all the sides along the bottom have to have the same length. I've got that roughly true here. We can say that both of those sides then, for instance, have length x. The other dimension, the height of the box, I don't know. It's not necessarily related to x. I can call that something else here, y. And now we're supposed to try to find the cost of the materials. So we have a top, we have a bottom, and we have the sides. So for those costs, the top looks like this, right? It's x by x. So it has an area, but then it also has a cost. So the area would be x squared, and then the cost, it says the top and bottom cost $3 per square inch. So I'm going to have to multiply the area by 3. The bottom, of course, is exactly the same. So it's still going to be x squared and 3x squared for a cost. The sides are different, right? The sides are like this here. It's going to have a x across the bottom, and the height would be y. So this would be my sides, and of course there are 4 sides as I go around this figure. The area of one side is x times y. The cost is only $2 per square inch, so it would be 2xy, but then I would have to multiply by 4 sides, so I would get a total cost for the sides of 8xy. So I have 3x squared, and 8xy. So I'm looking here for my cost, my quantity q that I'm trying to minimize. If 3x squared plus 3x squared gives me 6x squared, and then I'm going to have the sides 8xy. So that's my function q. Now the problem is I'm trying to minimize or maximize. I need to take the derivative of q, but there's 2 variables. So I need to look back here and say, is there another way of relating x and y together? And that's with this idea of the volume. So this is a prism. If I start with the bottom, it's a square. If I cut parallel to that square as I go across and up this prism, every cross section has the same area. In that type of situation, we can find the volume by just taking the area of the base times the height. And so what I would have here, that volume, the area of the base is x squared, the height is y, and that would have to be 768. I'm going to solve this for one of the variables so I can plug into q and get down to 1 variable instead of 2. It's going to be easiest solving this for y. I can just divide. And now I can substitute that back into my function for q. So we get 6x squared plus 8x times y. So this x will cross out one of these x's, and I'm going to rewrite it then using a negative exponent. So I'm going to get 6x squared plus 768 times 8. I'm going to have to do that. That's 6144. And I get x to the negative 1. And that's essentially the setup that I have for this problem. I'm trying to minimize that cost. And to minimize that, then I'm going to take the derivative. I bring the 2 down, I get 12x. I bring down the negative, and then I subtract 1 from the exponent. Negative 1 minus 1 would give me negative 2. So I'm going to have to get a denominator of x squared if I put this all together. So I'm going to have to multiply top and bottom here both by x squared. So that's going to give me my q prime is going to be 12x cubed minus 6144 all over x squared. And to find critical numbers, I'm going to look for where q prime is either equal to 0 or where q prime is undefined. Since q prime here is a fraction, it's going to be equal to 0 when the numerator is 0, and it's going to be undefined when the denominator is 0. So I'll set the numerator equal to 0. I'll add to both sides, and I'll divide. It goes in there 512 times. And now if I look at that, what's the cube root of 512? I think that would be 8, right? 8 times 8 is 64, and 64 times 8 is 512. So I'm going to take the cube root, and that's going to be 8. For q prime undefined, the denominator equal to 0, well, that would just lead to x equals 0, but that's not applicable here. That's not a valid length, and when I would try to solve for y, I'd get undefined. So although it is a critical number, it doesn't lead to a solution to this problem. I'm supposed to be minimizing the cost here. This is my critical number 8, and we're hoping that that's here, this place where it would have a horizontal tangent line. What I sort of need to check is what's happening if I put in values to either side of 8 into my derivative. So I'm going to want it to have it be decreasing at 7 and increasing at 9. If that happens, then I'm okay here. So what's q prime of 7? Well, it would be 12 times 7 cubed minus 6144 over 7 squared. You could plug that into a calculator or just think about it this way. If I were plugging in 8, my critical number, that would make this whole top equal to 0. If I plug in 7, this is going to be less than it was before, so I'm going to get a negative in the top, and I've got, of course, a positive in the bottom. So that's going to be negative, so it is decreasing at 7. If I plug in 9, well, the opposite's going to happen, right? Instead of plugging in 8 and getting these things equal, 9 is going to make this first one a little bit bigger, so I'm going to get a positive over a positive, which would be positive, and it would be increasing. So since it is decreasing at 7 and increasing at 9, it's having the behavior I want it to have, so that would be a minimum when x is equal to 8. So the dimensions then, we've got x equals 8. Oh, I didn't find y. All right, so what's y? Y, we've got over here 768 divided by x squared. So 768 over 8 squared. That's going to be 768 divided by 64, which is going to be 12, I believe, right? So it goes in there once, 128, yep. So we get y is 12. So the minimum cost occurs when the base is x by x, right? So that's 8 inches by 8 inches, and the height is 12 inches.